to be a little bit scared. So when it is systematic, that just means you have a very organized approach to how you're selecting people. So with this, I might say, I'm going to number people as they enter the room. So that might be like my first step. Number students.
Count students in the order they arrived. When you would hit 6, move back to 1. So it's like, so George 1, Alice 2, Jan 3, Catherine 4, Brian 5, Trent 1, Isaac 2, Victor 3, so on.
You could do it that way. You could also just number them all the way. 4, 5, 6, 7, 8, 9. Beckett, your way's fine though. There's no like one right answer for this, but whatever you pick, you just have to be able to describe. So I've numbered them as they come in, and then I have to tell you like, okay, great, what is my actual system? I'm going to system, I'm going to pick, I don't know, every third person starting with number 2. Like there's, I mean, as long as you define what it is, it doesn't really matter. So I'm gonna go.
That would not yield a vote.
Okay, I pick Alice. No, hold on. And then I go 1, 2, 3, 2, 3, 2, 3, 1, 2, 3, 2, 3, 1, 2, 3. How many am I up to? 7. So then keep going and go, okay, 1, 2, I'll pick Catherine. That's the third one because I already picked Alice. Does that make sense? Like, it doesn't matter what you do as long as you describe what you do. I mean, I wouldn't say pick the first 8 people who walk in the room. Have it be like every 5th person in line, every whatever the situation calls for, make sure you get to 8 people. Just say, you know, continue the process until I get 8 students to go on the trip. Yeah. So your second one could have been, I number them and I pick, you know, 2 people and then I skip 3 and I pick 2 people and 2. Like just some other method that's still a systematic approach. It's okay if you didn't. I ended up only doing one, but it's fine. Okay, but does that make sense? Like, so there could be very different answers for everyone. As long as you can describe what you're doing, that's fine. You can't just like number things and circle it and not explain anything though. That's not okay. All right? Because this would look really weird if I didn't explain what I was doing. You'd be like, what the heck? Why are you picking 2, 4, and 5 and then you jump to 8? Like that doesn't make any sense. Okay, so you have to be able to explain what it is that you're actually doing. Are we okay with that? Okay, so that's systematic. Nope, you're fine. I mean, I probably should write, these 8 students go on the trip, but. All right, then we're going to talk about designing an experiment. So everything we've been doing so far has been sampling methods and surveys. With experiments, you actually have some sort of treatment that you're using, and you're trying to actually look for a cause-effect relationship. So, again, I'm going to give you a second to read. You've got this page in your notes there. This is the difference between a study and an experiment. Guys, observational study, I may just be watching you and writing down whatever I see you doing based on a certain, whatever we're studying, okay? But there's no treatment, there's no, does this work or not work? I'm just observing and recording, okay? right? With an experiment, you are actually saying, okay, I have these subjects in my experiment. We're trying this placebo and this medication and seeing what works. Like you have a control group, all of those things going into it, okay? So an experiment has a lot more pieces to it. It's not bad, but it definitely has a lot more going on, okay? Okay, so what I want you to do here, go ahead and flip the page for me. Based on this little story here about drug A and cranberry juice, I want you to find the explanatory variable, the treatment, the response variable, and I also want you to think about what is the population, okay? So if we are doing this experiment, what is our population of interest? Explanatory variable. Our treatment. So what do you think, guys? Our population of interest, what do you think that is? The what? Okay, so when we're talking about population, usually it's like people of some sort. So we're going to say people with high blood pressure. Yes, exactly. That's our population of interest. All right, so our explanatory variable is just what are they consuming? Like the explanatory variable and the treatment kind of go together. So the explanatory variable is what is consumed. And then the treatment, what are the two choices for things that are consumed? Yeah, we've got drug A and cranberry juice, right? That's what we're trying to test here. So then your response variable would be, what are we measuring at the end to see if these treatments had any impact on
Blood pressure.
Yes, that is your response variable, blood pressure. Okay. Those things make sense to you. It's like multiple choice type question, like here's the scenario, identify for me these different things, okay? We'll actually design an experiment next based on this. All right, so now we are going to actually create a completely randomized experiment. I'm going to do it for you like sort of a little flow chart first, and then we'll write down exactly what we're talking about. So the first thing you begin with, you have to have subjects. So you're going to select subjects. And this is from our population of high blood pressure people. Right, that was our population of interest. So there's our people. Okay. All right. From there, we have to decide, do they get cranberry juice or do they get drug A? So, juice. They're split into these groups. One gets juice, one gets drug A. Guys, this is where the randomization comes into. So the treatment is randomly assigned. One of the easiest ways to randomly assign your treatment is just flip a coin. If you get heads, they get juice. Tail, they go to the drug A group. Okay? So make a little chart like heads. Tails. Note in some way, what did you do? Like coin flip, H and T. So you have some way of noting, like, yes, this is randomly assigned to the two treatment groups. Okay? You should specify what the treatment actually is. I don't think they told you in here. Usually they'll give you information like you get 8 ounces of juice 2 times a day, something like that, and your drug, you take 1 pill per day. You want to make sure, if that information is given to you, that you clearly include that in your experiment. Then guys, what do you think we're going to do after they've been taking the medication or the juice for a certain amount of time? Yes, measure blood pressure. You're going to do that for both groups. And what do you think you do? Yeah, you compare your results, okay? I think designing it visually like this is much easier than just like step 1, select participants, step 2, going through that. In your packet, if you flip the page, it's actually all laid out for you. On the last page for the front of it, actually, it's on the second method. It says basic design method, completely randomized design. So this is a very wordy way of going through how you design your study, or your experiment. And then step 3, that's just kind of the outline of what we did, but we did it in this form. Okay? Does that make sense? You're also going to have still like a null and an alternative when you set up an experiment. Okay, so you'll start with that so you know what you're trying to test. Okay. All right, let's look at blocking. Okay. Anybody know what blocking is? Like we see it's to reduce variability and possible sources of bias, but what do I mean by blocking in an experiment? Any thoughts on this cranberry blood pressure thing? Kind of like grouping. You have a reason to put people in these different blocks. Let's go through it. Let's start again. We'll see if you can see it. So you start with your subjects. So exactly like we did before. We have all of our people. But before I randomly assign treatments to them, I'm going to put them into 2 groups. I'm going to have the female. I'm going to have the male group. Could medications react differently than in women? Okay, so you might want to look at that when you're doing your experiment. Okay, so there is no randomization there. Like, they are specifically put in these groups based on a characteristic, okay? All right. From there, then, this is where the randomization comes in. So we will, for each of these groups, we have juice, egg, juice, okay. You can be assigned one of those two groups. So and again, you want to tell me like, okay, heads was there, tails was there. Heads, tails, coin flip, okay, somewhere like that. So I basically have 4 groups now that I'm looking at. I have 2 different juice groups, 2 different drug groups. What am I going to do with the subjects in each of these groups after they've had this treatment for whatever the allotted amount of time is? Yeah, we're still going to measure blood pressure. So for every single one, we'll check blood pressure. And then we're going to compare, but the comparison is going to be within these 2 blocks. So I'm going to compare the women, the females with the juice and drug A, and then I'm going to compare the males, juice and drug A. Okay, so do you see the differences between blocking and just a completely randomized experiment? Yes. What you're doing by blocking is saying, I think it might be completely different from one group to the other, so I need to look and test it only on subjects that are very similar, and then only test it on subjects that are similar. So this is the only comparison that you're going to make. And then you'll talk about your results from both blocks, okay? All right. Questions on that, guys?
Would you actually compare the male and female?
That's what Stacey was just saying. Now you're going to look, because you blocked it on purpose because you think like there's a characteristic in this group that's going to impact looking at it, so that's why you do it separately. Okay? So let's keep going. Matched pairs design we've talked about a little bit. We're going to look at the add-on you guys have in your notes. Let's see if I actually have it up here. That's not helpful to you at all. Whew. Okay. Okay. All right. So we'll get to the matched pair stuff here in a little bit. Let's go ahead and go to blinding, double blind, and the placebo effect. We're skipping that principles part, I know. Have you guys heard of these, like a blind, like research done, blind, double blind, or the placebo effect, all of that? Okay, yes, these are terms you're usually pretty familiar with. But go ahead and jot down those definitions for me. Why do you think it matters to have a blind or a double-blind experiment or study? Yeah, so you aren't like, oh, I have the medication, I'm clearly going to get better, or no one is influencing you in any way or influencing the experimenter. If it's double-blind, like you're not looking for certain results in certain people because you have no idea who got which treatment plan. Okay, it just removes some of the bias from your experiment. Everybody okay with these? And then let's talk about blocking again, comparing it to stratifying. So they're very simple, or similar, sorry. So blocking is to an experiment the same way stratifying is to a sample, okay? You're never going to stratify in an experiment, but you can block in an experiment. You will never block in a sample, okay? Two words that mean very similar things. It just depends on what are you doing. Are you doing sampling method or are you actually conducting an experiment? Okay? So, like circle this. Do something with this. Okay? The arrow means is to. Understanding similarities and differences between those is pretty crucial. Here's some multiple choice questions. I put a packet on your desk for you too, okay? Okay, guys, here's some of your extra stuff here. Really in this unit, what we're doing is breaking down the differences between doing an observational study and an experiment. Observational studies, again, you are observing. It's in the name, okay? That's all you get to do. You just get to watch and record things. It sounds kind of creepy, but that's what you're doing in an observational study. We'll talk a little bit about lurking and confounding variables. These are like hidden things that could impact the results of what you're observing. And so you need to be aware of those. You need to do what you can to eliminate the lurking or the confounding variables. And then the biggest difference in an experiment, you're going to have a control group. Okay? You're not applying any treatment in an observational study, so there's no way to have a control group. You're just looking at the group of people and observing or surveying them with questions. In an experiment, you will actually try to define a cause and effect relationship. Okay. Some things you need to remember when you're designing an experiment. You want to have a control group. There needs to be randomization, either in the assignment to the groups, the assignment of the treatments, how you're doing that. And then replication. You need to have an experiment that can be repeated. So you need to ask yourself, can this experiment be repeated? If it's poorly designed, you may not be able to actually repeat it. Okay? All right, and then this last page here, the front of the last page, this is what we talked about when we were sort of drawing out our experimental design, completely randomized design. That's the first part we're doing. I'll give you a second to read through that. If you guys have questions on any part of it, let me know. This is kind of what we did with our flowchart design. Why do you think this is important? Who gets which treatment must be out of the hands of both the subjects and the person doing the experiment? Why do you think that matters? Yeah, you could completely influence the results. If you have a group of people, and for whatever characteristic you think, ooh, these 5 people, I'm pretty sure they're going to respond well to this medication, and you intentionally give them the medication, that is bad. That is not a well-designed experiment. Okay, your results are not going to accurately reflect how well the medication works. Okay? All right, and then last page, talking about blocking a little more. Again, this is repeated, I know, because it matters. Blocking is to experiments, and stratifying is to sampling. Go ahead and read through the blocking part, and then read through matched pairs. We talked about this, I think it was in Unit 6, we did matched pairs with your hypothesis testing. Read through that. If you have questions, let's talk about it. Do you remember matched pairs? Yeah, okay. All right, I know there's a lot of words in this unit, okay? I think we just need to practice some of these so you can just get used to using the different types of experimental design. So any questions before we step notes? Okay. It's your last